So good afternoon, everyone. Welcome to today's online facilitation for drilling engineering course. My name is Ajebi Isaac, and I'll be taking you through the schedule for week 1 and the topics that you are going to be learning. So I'll kindly share my screen to start. Okay, so once again, you are welcome. And today we are going to be discussing on drilling fluid functions and circulating system. We look at the drilling fluid functions and the circulating system. Before we start, I'll just give us a brief introduction about drilling. Now, drilling is the way by which we get to the oil or petroleum that is underground. The petroleum products that we see, they are all made from what we call crude oil, and it is a kind of fluid that contains hydrocarbons, and it is very useful. There are so many components that are in it. In it, you can find bitumen, we can find kerosene, we can find the fuel that planes run on. We can also find petrol that our cars run on. The LPG gas that we use in our homes is also found in crude oil. But this valuable product or resource is found deep within the earth crust, and we have to drill for it. It can be found so many miles or so many feet within the earth. So that is what drilling engineering is about. And we are going to look at certain components that helps us to perform this drilling. So one of them is what we are going to look at here, called the drilling fluid. We'll look at the functions of it, and then the process by which we use the drilling fluid in drilling. So once again, my name is Ajebi Isaac, and then we move over to the next topic. So looking at drilling fluid functions and the mud circulating system. So first of all, we look at the contents. We'll be looking at what drilling fluid is, and we'll be looking at types, the various types of drilling fluids that we have. We'll also be looking at the functions that this drilling fluid performs in the drilling operations or processes. And lastly, we'll look at the drilling fluid circulation system. It's a fluid, so we need to circulate it through the well and as we drill, okay? So first of all, we'll also see the learning outcomes at the end of this chapter. The students, we are expected to be able to describe the drilling fluids, what they are. We are also expected to be able to list the types and functions of the drilling fluid in different formation environments. When we say formation environment, we are looking at rock environments or the ground environments. And we are lastly also expected to describe the drilling fluid circulation system that occurs during the drilling processes using drilling fluid. So firstly, when we ask yourself, what is drilling fluid? Drilling fluid is a liquid, or it could be gas, or it could be gasified liquid, which is circulated through the drill string into the wellbore and up the annulus and back to the surface during drilling operations. So I'm going to describe to you what we are. I'm sure we are thinking, what is annulus, what is wellbore? We are going to see them as the course of the lecture goes. And we are going to see how drilling fluid also is used in drilling processes. And also, when we talk about drilling fluid, it's normally a gray-brown color, and it is muddy in texture. So if you look at the picture just where my cursor is, you can see it looks like your normal mud or dirt that has been mixed with what? Water. So that is how the drilling fluid looks like. Okay, that's the color of it mostly. It's a combination of different components such as bentonite, a form of cement that allows the drilling process to take place easily. So let's move on to the types. So we have the types of drilling fluid. Remember we said that it could be gas, it could be liquid, or it could be gasified liquid. So the first type is the gas-based drilling fluids. The gas-based drilling fluids, okay, they are normally a combination of, let's say, gases and mist. It could be mist. That means water droplets in gas. And they are potentially used in what we call the lost circulation zones. During drilling processes, there are certain formation zones or there are certain parts of the ground that have a lot of holes. And if we are dealing with a fluid material being pumped into the well, okay, it could be lost into the formation. That means it could flow into the ground and we could lost it. It will not come back to the surface. So that process is what we call lost circulation. And there are zones that are responsible for this where we could have lost circulations. So these zones are where we use the gas-based drilling fluids. And we also use it in the reservoir pressure zones that are low, and also in what we call the underbalanced drilling operations. We'll get to know more of that as we go. So now the first type of pneumatic or gas-based drilling fluid is what we call the dry air. The dry air, it functions majorly to remove drilled cuttings, and also it helps to cool the BHA. This particular type has common features or common functions as other drilling fluids. But we notice that the dry air is limited in the water and oil producing formations and in mechanical or mechanically unstable well bores. So the well bores that can easily cave in. If you have a hole or a drilled well or a drilled hole where the materials that you are drilling through, let's say the sand, are getting back into the hole, they are not staying. The walls of the well or the walls of the drilled hole are not stable. So after you remove your drill bit, you notice that it goes back inside. So that is what we call cave-ins. So we said that such a well bore is mechanically unstable. So dry air drilling fluid is limited in such a place. Let's look at the next type of gas drilling fluid. We have the mist. The mist type is formed when water is injected into an airstream, okay? So a mixture of water, so we have the airstream going into the wellbore whilst you are injecting droplets of water. So it forms what we call the mist. And the mist type also functions like the dry air, but is more effective in the formations that produces small amounts of water. Remember, we said that the dry air is limited in water or oil producing formations, but the mist is more effective in that. Let's look at the next one. We will call the foam type of gas drilling fluid. The foam, so foam is formed when water and certain foaming surfactants. So when we say surfactants, it's just like your soap. You know, when you put soap inside water and you shake the water, you see it begins to produce what we call the foam. Okay, the guys can also picture it to be like your shaving powder or the shaving foam, the one you apply before you do the shave. I can see a hands up from Foster. Please, can you indicate, Foster, can you tell us your question? What's the question that you have?
Sir. Hello, sir.
Yes, please.
Please, during the class, I made some research and I got to know that the drilling fluid can be used to prevent blowout, but I didn't get much understanding on how the drilling fluid can be used to prevent blowout. Thank you.
Okay, thank you very much, Foster. Drilling fluid can be used to prevent blowout. I'll explain that just after the presentation. Please remind me. Thank you very much.
Thank you.
Yes.
Thank you.
So continuing with the foam, okay, the foam has more dense properties than the dry air and then the mist, okay. It functions like the dry air, but then it's more effective in the lost circulation zones, in the sense that because of its density, it does not allow free flow into the formation. Yes, so that is one advantage of the foam over the other type. Then we have the last type of drilling fluid, which is gas-based. We have the gasified mud. So it is formed when nitrogen or air is injected simultaneously with the circulated mud slurry into the drilling string or the drill string. So when we say that the mud slurry is a combination of, just as we looked at it in the earlier ones, this type has more water, okay, or more oil in it, more water and more oil in it. So you inject either nitrogen or normal air or a certain form of gas into the water-based drilling fluid. So you get a gasified mud. And this type of mud is effective in weak formations, which has a low fracture gradient. When we say something, the formation has a low fracture gradient, that means that it easily fractures or it easily breaks. So the rock zone, when you apply so much force, okay, it can break up the rocks easily. So that makes it a low fracture zone. In this case, you will not need a fluid with high pressure. And that's when we use a gasified mud for that. Now, when we look at the general advantages of the pneumatic fluid, okay, we have an improved ROP, which is the rate of penetration. So the rate at which the drill bit penetrates through the ground during drilling operations, okay, when we look at that, it's improved when you use the pneumatic drilling fluids. And it also helps to preserve the bit life, the drill bit, the life of it. It preserves it, you know, when during the drilling, okay, processes, the drill bit experiences what we call the wear and tear because of friction. So as it is breaking or coming in contact with the rock surfaces, there is heat produced and there is friction also produced. So it can cause wear and tear of the drill bit itself. But when you use the pneumatic drilling fluid, it helps to preserve or prevent the wear and tear of the drilling bit and extend the life of the bit. Then we also have a better control of lost circulation zones. So as I earlier explained, then what are some of the disadvantages? So the disadvantages, some of them is that this type of drilling fluid, which is gas-based, is not economical because there are certain gases that are expensive to get in large quantity. They may be very expensive to get in large quantity. So in that case, it makes it difficult or not cost effective. So it's not economical compared to other drilling fluids. Then we also have possible downhole fire. Remember, we are dealing with gases, and gases have a higher flammability than liquids. So in that case, due to the friction that is produced by the drilling fluid rubbing up on the surface of the rocks during drilling, there can be a spark because friction comes with heat. There can be a spark. And if the gases are flammable, it can easily light up. So there's a possibility of downhole fire. Or when we say downhole, that means that the drilling hole, the hole that you are drilling could light up. Then we can have possibility of corrosion. Remember, you can have acidic gases which are mixing up with your drilling fluid, which is gas-based. And then when these acidic gases are used along with metals, they can corrode the surface of the metals. So we can also have possibility of hole deviation. If we don't get a streamlined or a controlled flow of the gas during the drilling process, it can let your hole have a certain direction that is not according to your target. And then we can have frequent hole erosion. Now let's look at the second type of drilling fluid. We have the liquid drilling fluids. And we said that when pneumatic drilling fluids cannot be used because of maybe economics or other activities, then we have to go in for liquid drilling fluids. And then we have types for the liquid drilling fluid. We have the clear water drilling fluid. In preparing this kind of drilling fluid, you have to use either fresh water or seawater. So it could be fresh water or seawater. And an advantage is that it is the most economical because we have fresh water in abundance. You could use lakes, water from lakes, or water from streams. You could use water from hello. Can we all hear me?
We can hear you.
Okay. So I was saying that with the clear water, you can either use seawater, okay, and it's in abundance, so it makes it more economical. And using this type of drilling fluid, it makes us achieve higher rate of penetration, and also it helps with the longer bit life. So the drilling bit, it helps to preserve it more. But then one thing about the clear water or the normal water is that it is limited in abnormal pressure zones. We have zones that have abnormal pressure. Okay, the pressure there may be very high or extremely high. So in our analysis before we drill, we have what we do, the pressure sensitivity analysis, so that we know the zones or the formations that have abnormal pressures. And we can't use the clear water during this part or this portion. So we also say that it's disadvantageous in the water sensitive formations. So there are some rocks or some zones that have higher conductivity or low resistivity. When you use water, since water is conductive, it can affect some of your, what we call your logging, your information that you are getting during the drilling process from these formations. You can either have higher sensitivity or higher electrical charges in these zones. And then also in mechanically unstable wellbores, like I explained about mechanically unstable wellbores, you can have water washing off the surface of the wellbore. Now let's look at the next one. We have the next one, which is water-based drilling mats. But then this is water combined with other components like other gases or some form of polymers, okay? And the main advantage of this is it increases the density of the water so that it can, during the drilling operations, certain fluids cannot invade your wellbore. I think we'll look at that when we are talking about underbalance and overbalance drilling. So because of our time, I would like to speed up a little. Then we have the oil-based mats, okay? So when we say something is oil-based, that means the most abundant component of that formation or that fluid is oil. So it may be diesel, mineral, or synthetic oil. And these are advantageous because they are very unreactive to acidic gases such as H2S and then carbon dioxide and certain salt formations. So when we are using this fluid in zones like active shale, it is very advantageous because it does not react with the formation. So it's mainly applied in high temperature formations and then water sensitive shales and the rest. It also prevents corrosion during drilling. Now let's look at the next. Let's look at the functions of the drilling fluid. We have the major functions, we have the minor functions, and then we have the other functions. So the major function of any drilling fluid is to suspend and remove drilling cuttings. Drilling cuttings are what you see here. They are the rock particles that has been broken within the wellbore. You also have to get it out. So when you circulate your mud within the wellbore through the drilling string, it comes through the annulus and then it washes up the rock cuttings. That is one of the major functions of every drilling fluid. Then we also have containment of subsurface formation fluid pressures. So when we look at this, the fluid, there are pressures from the formation which are trying to invade your wellbore, and you need to prepare your drilling fluid to be able to balance that pressure, to exert a certain level of pressure on the formation so that fluid from the pressure does not invade your wellbore. Now I want you to picture the wellbore as a pressurized zone, just as when you buy a Coke bottle and you shake it, you know that the Coke in it is pressurized. So once you poke it, you notice that it is trying to force itself out. That is how the wellbore is. So you need a drilling fluid that will help you to contain the outcoming wellbore pressure. That is what Foster asked about a blowout. So your drilling fluid needs to be able to control what we call your blowout. Okay. So we have underbalanced drilling and then overbalanced drilling. Underbalance meaning that your formation fluid pressure may be very low. So your drilling fluid can go into the formation. Do you see it? It can escape into the formation. So you need to prepare your drilling fluid to be able to counter that. And then the overbalanced drilling pressure is what we call that the formation fluid would be invading your wellbore. Okay. So the next major function is the hole stabilization, sorry. So you need to be able to, the drilling fluid needs to be able to stabilize your hole and make it not destroy your formation. And one of the ways it does this is that it forms what we call a filter cake. So you can see a filter cake just on your wellbore surface, which prevents any fluid from going into your formation and any other fluid from coming out of your formation. Now, quickly, let's run through the minor functions. So we have cooling and lubricating of the drilling fluid. Okay. So the drilling string rather. So the drilling string and the drill bit needs to be cooled from time to time because of heat production during drilling. And then it needs to be lubricated. The drilling fluid also needs to reduce the weight of your casing string. We have a lot of components that are dipped, that are joined together and dipped to form the drilling string. Then this is suspended within the wellbore. So the drilling fluid helps us to suspend the weight and reduce the weight of the casing string in the wellbore. Then we have, it also helps in formation evaluation and cleaning of the drilling bit from other mud particles that are inside the wellbore. We have other functions which has to do with minimizing the effects of corrosion and then enhancement of the rate of penetration. Okay, and the minimal environmental impact. And also it enhances safety, okay, in the process of drilling and reduces frictional pressure loss. Now let's quickly run through the mass circulation system. So the mass circulation system is a system that we put in place which describes how the drilling fluid is pumped into the wellbore and is brought out and cleaned and re-injected into the wellbore again. So we have the components, we have the mud pump, we have the pump manifold, we have what we call the standpipe, the swivel, the drilling string, the annulus, we have the mud return line, and then the shale shaker, the desander, the desilter, and then the degasser. So, and lastly, the mud pit. So we'll look at all of them in description in the next slide. Now, we have, this is the mud circulation system. So I'll explain them one by one, what we just mentioned in the previous slide. So we have, first of all, the mud pit. The mud pit is where you keep your mud. This is where the mud or the drilling fluid is also referred to as mud, remember. So this is where the mud is prepared. So the mud engineer is the one that formulates the drilling fluid or the drilling mud. He combines different components, cement, water, oil, and then some additives. And this is where it's prepared. It's prepared in the mud pit. And then from the mud pit, there is what we call the pump. This mud pump pumps or sucks the drilling fluid from the mud pit through the suction line. Okay, this is the suction line. And then it sucks it and then pumps it through what we call the discharge line. Okay, so there is this component here. Just it functions as your normal pump, your water pump that pumps water from, through your pipes, through your taps in your homes. Okay, so it functions exactly like that. But this one is specially designed to pump in thicker or denser or more viscous fluids. So it pumps it through the discharge line and it goes through the standpipe. Now the standpipe is a very tall vertical pipe, okay, that is that helps the drilling fluid to get to a certain height so that it can easily go through the top of the drilling string. Now when you look at this component, this is the drilling string. The drill string, it's a combination of joint drill pipes, okay, which are connected in series, very, very long. It can be as long as from here. For those of us who know Koforidua, it can be as long as from here, from main campus to the runabout. So let's say we can have it as about 5 kilometers in length. So it contains sections of or joints of drill pipes. So it's very, very long. But then this standpipe helps to raise the mud to a certain height before it moves through the drill holes. And then it gets to what we call the swivel. The swivel is what allows the drill string to rotate whilst keeping it stationary. So it has what we call the gooseneck. The gooseneck is what allows the drill mud to go directly into the middle of the drill string, and it pumps it within the drill string down to the well bore. Now, this is the beginning of your well bore. Your well bore is like a hole, okay? And then this is the top of it. So when it goes in, the drill mud is circulated through the drill string into the well bore, and it gets to this place where we call the drill bit. Now the drill bit is what we saw at the beginning of the slide. That is an example of a drill bit. It's a hard metal substance that helps to crush the rocks as drilling is going on. So that is what makes it drilled. So the drill bit has a hole in the middle part of it, and these holes are called nozzles. That is where the drilling mud passes through and goes to wash the bottom of the hole, and then it passes through the annulus. Okay, the annulus is this portion, that is the space between the drill outside part of the drill string and then the walls of the well. So it passes through the annulus and returns back through the mud return line. So it goes to the surface and then it goes through the mud return line. Now the mud return line is on the surface of the earth, okay? And then the well bore is deep within the earth. So when the drilling fluid passes through the mud return line, it gets to a first component, which is called the shale shaker. It works like a sieve, okay? And then this shale shaker, it sieves out bigger rock particles that are inside the drilling fluid. So it sieves it out, the bigger rock particles, leaving the drilling fluid and some smaller particles or smaller rock particles, okay? Then from there, it moves to the desilter. Now, silt is a smaller rock particles, which is of, let me say, a size like a normal stone, a normal average stone you see outside. So this component here, where the red cursor is blinking, helps to remove the smaller rock particles, and then it leaves sandy size particles, okay, within the drilling fluid. And from there, the drilling fluid goes to what we call the desander. The desander is a component or a machine that helps to remove sand particles or particles that have a size of a sand, okay? So the sand size is what we see at the seashore or the beach. The sand, that is the size. So all those particles that are of that size will be removed by the desander. Then the next stage, it goes to the degasser to remove gases like the H2S or the CO2 or poisonous gases that are unwanted, sulfuric gases, okay? It cleans the drilling mud of all these sulfuric gases. And from there, it goes back to the mud pit, okay? So in the mud pit, which is in the mud tank, the engineer will come back, the mud engineer or the drilling fluid engineer will come back, take a sample, and then test to see whether the drilling fluid still maintains its right properties and checks whether it is okay to re-inject into the well bore again to continue the circulation process. If it is not okay, then the mud engineer will maybe, if it needs more weighting materials or more materials to make it improve, then the mud engineer will mix everything back in the what? In the mud tank or the mud pit, and then the circulation continues again. So this is the cycle of the mud circulation system or the drilling fluid circulation system. And this is normally applied. It goes on continuously. There is no stopping. It goes on continuously during the drilling process, and it helps us to drill effectively. So at this place, I'll take in questions from us. So with your question, the question you asked about the blowouts, okay? So the drilling fluid helps to prevent blowout. Blowout is the forceful coming out of fluids or liquids from the wellbore without control, okay? So just like you picture your Coke bottle that you shake, when you open a little part of it, you notice that the Coke fluid comes out forcefully. That is what we call a blowout. That is an example of a blowout. So the way to do this is to make sure that you formulate your drilling fluid to have denser materials within it, to have denser materials within it. So we have to formulate our drilling fluid to have denser materials within it, and it will help us to overcome the blowout. Please, any other question before we close the class for today? Do we have any other question from anyone?
No, please.
Okay. All right. So in the absence of no questions or any questions, we'll move to the next class by next week.
Sir.
And
Sir. Hello, sir.
yes, please.